This conference will now be recorded.
Hello students, I'm Dr. Divya from TeenEinstein.
This conference will now be recorded.
Students, I'm Dr. Divya from TeenEinstein. In today's class, we are moving to the second part, next part of this chapter, environmental issues part 2. So in this part, we'll be learning about some case studies. So in part 1, what and all we have discussed, we learned about pollution and how this human population and population size that is increasing, and the rate or the percentage of pollution, how it is increasing along with this human population increase. And the agents which are bringing this undesirable change, that undesirable change, we are calling that change as pollution. And those agents which are making these undesirable changes, they are called as pollutants, right? And then we learned about air pollution, and this air pollution is causing different respiratory diseases. So these air pollutants, the particles which are making, or the agents which are causing the air pollution, they are called as air pollutants, and that must be separated. Then only we will get unpolluted air. So that particles must be separated. Then through which and all methods we can separate these pollutants, that we learned. So most widely used method, that is electrostatic precipitation. So in last class we explained how that electrostatic precipitation works. Then we learned about noise pollution, and in noise pollution above 150 decibels or more than that, that may damage the hearing ability. So that much we learned. Then in this class we are starting with a case study on air pollution. Okay. This is case study on air pollution, a case study of Delhi. That's what we are going to discuss now, case study of Delhi. So in this, you know, Delhi, that is having a very large population, and in vehicular traffic also in a higher position. So Delhi, that is a leading place in our country in the case of air pollution, not in other things, in air pollution. So that is having more vehicles or more cars compared to other states. And in 1990, Delhi ranked fourth among the 41 most polluted cities of the world. In the case of pollution, Delhi is in 4th position in the world. Delhi ranked 4th among 41 most polluted cities of the world. Okay. So this air pollution issue, it became a very serious issue in Delhi, and from public side, what they did, public interest litigation that was filed in Supreme Court. Okay. Due to that much pollution in Delhi, we said already it is in 4th. Not now, it was in 4th position among 41 most polluted cities of the world. Okay. So that became it was in a very dangerous situation and became very serious issue, and public filed a litigation in Supreme Court. Then after that, government asked to take necessary actions or appropriate measures within a specific time period. So as a part of that, what kind of control measures they suggested? They suggested like switching over of entire public transport method from diesel or petrol to the compressed natural gas, CNG. So instead of using petrol or diesel, they asked as a necessary measurement for this pollution, air pollution, they took a necessary action as a control measure. So what they did? Switching over entire public transport. That means all buses, cars, or vehicles, all kind of vehicles from diesel to compressed natural gas, CNG, compressed natural gas. So all buses or all public transport vehicles, they converted and they started running on CNG, compressed natural gas, by the end of 2002. So what is the benefit, or why? The question, we'll get a question that why CNG is better than diesel. What is the reason? What is the advantage of CNG over diesel or petrol? That is the next question in this case study, right? So definitely you will think about that. What is the advantage over petrol and diesel in the case of CNG? So what will be the answer? The answer is CNG, or compressed natural gas, that burns most efficiently. Not like petrol or diesel. It is burning efficiently in automobiles. And very little of that is left unburned. Okay. And CNG, compressed natural gas, is cheaper than petrol or diesel. But there comes a major issue. The main problem where they are facing to switch over to CNG, what is the difficulty? The difficulty of laying down pipelines to deliver CNG through that distribution points or distribution pumps. Okay, so we need to make sure that that supply is uninterrupted, right? So for that, it is only in the supply they face the problem. The main problem to switch over to CNG is the distribution. Okay. Then, not only this one, parallel steps. Along with this, parallel steps were taken in Delhi for reducing the vehicular pollution, which is mainly from the old vehicles. See, old vehicles you can see. So old vehicles we are using means that also may create more pollution. Then use of unleaded petrol. Then use of low sulfur petrol and diesel. Then use of catalytic converters in vehicle. Okay, so all these. See, if you are using CNG, that will reduce. compressed natural gas, if you are using, that will reduce pollution. Then if you are using low sulfur petrol and diesel. So all this, not only the CNG conversion, they took all parallel measures to reduce the pollution. So to cut down that vehicular pollution in all Indian cities, the government of India, they brought a new auto fuel policy, and for fuels also more stringent or more strict conditions like reducing the sulfur and aromatic content in petrol and diesel fuels. Okay. See, in Euro 3 norms, in that, like for example, we are saying that sulfur, that stipulated that sulfur to be controlled at 350 parts per million, 350 ppm sulfur in diesel and 150 ppm in the petrol. Okay. And aromatic hydrocarbons to be contained in which level? In 42% in the concerned fuel. Okay. So according to that roadmap, it is reduced sulfur to 50 parts per million in petrol and diesel, and they were able to bring down that level up to 35%. Okay. Then not only this, the fuel engines that concern corresponding to that fuel, which fuel we are using, along with that, that fuel vehicle engines also to be upgraded, right? That is also a necessary movement. So because of all these efforts which they have made together, from there they got a result, and Delhi, they got city that got improved in a very significant way, and according to that, there is a fall in the carbon dioxide and sulfur dioxide level in between 97 and 2005. Okay, they made a substantial fall in carbon dioxide and sulfur dioxide level. So if we want, we can make or we can reduce pollution, right? So we can reduce pollution if we want. If we are trying, we can reduce. But here in India, we will never try. We'll never keep our city clean. We'll never make our city or our place pollution free. Right? We are not taking necessary action towards that. And next comes water pollution and its control. See, in this picture, you can see how dirty this water is or how much that got polluted. So all these are through human activities. So human beings, you know that human beings, they are spoiling the water bodies around the world. Through which and all actions, they'll dispose all kind of waste into that. And what they are thinking, if you are throwing into water, it will go away. See, they are removing that waste material from their home or from their compound, and they'll throw that into water bodies. So disposing all kind of waste into water bodies. And we are thinking that water will wash away everything, right? But we are not realizing that it is coming back to us only. In another form, it is coming back to us in the form of diseases or in the form of worms or in the form of viruses. In all forms, it is coming back to us only. And see, we should understand that these water bodies, they are our lifelines, not only ours. Some other organisms are there, all living organisms are there, aquatic organisms are there. They also need to live. So due to human activities like stream, pond, river and all, they are becoming more and more polluted. Day by day, it's becoming more and more polluted in different parts of world, right? So we have to understand the importance of maintaining clean water, or how clean we should keep our water bodies. That important we should understand. So for that, Government of India has passed the Water Act for prevention and control of pollution. Water Act in 1974 for what? To safeguard our water resources. That is for the prevention and control of pollution. Okay. So in 1974, to safeguard our water resources in India, they passed the Water Act for the prevention and control of pollution, or for the prevention and control of water pollution. Okay. Next. Next is domestic sewage and industrial effluents. See, what usually we'll do, we are washing everything into drains, right? In our home or wherever, maybe we are washing everything into drains. So where this water it is going, finally where it is reaching, or what is happening in villages. See, whether we need to think in villages, whether they are doing any treatment, water treatment before sending that to the river or any water bodies. See, all these, whichever water we are using or we are pouring into drains, it is reaching into some water bodies, right? So before sending into that, we should think whether they are treating that properly or not. That sewage water is treated before being transported to any water bodies, any nearest river, or before getting mixed up. See, we know that solid waste, if you are throwing any solid waste, that will be comparatively, that is easy to remove. Then which one is most difficult to remove? See, here you can see impurities, 0.1 percentage. That 0.1 percentage, see, suspended solids like sand, silt and clay. That is suspended solid waste. Then colloidal material like fecal matter, bacteria, cloth and paper fibers. All these are colloidal materials. Then dissolved materials like nutrients, ammonia, sodium, calcium, nitrate, all these. These are dissolved materials. So that is the composition of water. So here water 99.9% and this impurity is 0.1%. Yeah, that impurity that is composed of all these suspended solids, colloidal materials, and dissolved materials. So solid waste, they are comparatively easy to remove. So you know that 0.1% of impurity that is making the domestic sewage unfit for human use. So due to that 0.1%, that sewage, that water is becoming unfit for human usage. And the solids, solids are easy to remove. So which is most difficult to remove? The most difficult one to remove, that is dissolved salts like nitrate, phosphate, and other nutrients. Then toxic metal ions will be there, organic compounds will be there. All these things are very difficult to remove. Okay. So this domestic sewage we said, that is mainly that contains biodegradable organic matter. Okay, biodegradable organic matter. Domestic sewage mainly that is containing biodegradable organic matter. So this biodegradable organic matter, this we can decompose with the help of bacteria and other kind of microorganism. So this domestic sewage that is mainly containing this biodegradable organic matter, and this organic matter, it is easy to decompose. How we will decompose? With the help of microorganisms and bacteria and all. So that can be, these microorganisms can be multiplied by using organic substances, and these organic substances will work as substrate. So these microorganisms, they will utilize the sewage components for their growth. So they will utilize that sewage components for their growth. And how we can estimate that amount of biodegradable organic matter in sewage water? We can measure the biochemical oxygen demand, BOD, biochemical oxygen demand. Through that, we can measure the estimate of biodegradable organic matter in sewage water. Got it? So in domestic sewage, which is unfit for human usage, in that you can see 0.1% of impurities. And these impurities in the sense that consists of suspended solids, colloidal materials, then dissolved materials. Among this, the suspended solids, they are easy to remove. Compared to other two, the suspended solids are easy to remove. So the most difficult ones are the nutrients, then toxic metal ions, organic compounds, salts like phosphate, nitrates and all. So those things are difficult to remove. Okay. So the domestic sewage that mainly that contains biodegradable organic matter, and this can be easily decomposed. How we can decompose this? With the help of microorganisms and bacteria. Okay, while growing these microorganisms or bacteria, this will use this organic biodegradable organic matter as a substrate, and they will utilize that energy for their growth or for multiplication. Okay. So by measuring this biochemical oxygen demand, we can measure the biodegradable organic matter amount which is present in the sewage water. Okay. So next, here you can see a diagram or a graph. Here you can see this graph. In this, that shows sewage discharge. When it is discharging that sewage into a water body. Okay. When that sewage, it is reaching into a river. So in that, microorganism which is involved in the biodegradation, that will consume lot of oxygen, and as a result of that oxygen utilization, there will be a decline. That also a sharp decline you can expect in the dissolved oxygen. From where? At the point of sewage discharge. At the point of sewage discharge, that dissolved oxygen will decline. A sharp decline you can see, and that causes the death of aquatic organism. Like fish and other aquatic organism may die due to that sharp decline in the oxygen level. Okay. See, these organisms, see, this is the direction of flow, and this is the concentration. So this organism, they will use this biodegradable organic matter, and that will consume a lot of oxygen. So as a result of that oxygen utilization, a sharp decline in the dissolved oxygen we can see. So that causes the death of, or that creates the mortality of fish and all other aquatic organisms. Then here you can see large amount of nutrients which is present. See, sewage water is going to a river. So there will be large amount of nutrients in that water, and that causes excessive growth of planktonic. That means free floating algae. Okay, excessive growth of free floating algae you can see in water bodies like this, wherever the nutrients are more, like this free floating algae you can see. Yeah, you have learned about this algae. This is called as terror of Bengal, right? So free floating algae, that is called as algal bloom. Large amount of nutrients will be present in that water body, and that may cause the excessive growth of free floating plants or free floating algae, planktonic algae, that is called as algal bloom. So that gives distinct color to that water bodies. So algal bloom, that reduces the water quality. Okay. And that algal blooming, that may cause again the death of aquatic organisms like fish and all. That may lead to the death of fish also. Then some algae like this, some blooming algae, they are extremely toxic. They are very toxic to human beings and other animals also. You might have seen some colored flowers. See, here you can see iconia, the colored flowers, and that will be very beautiful, and that will be like some kind of shape, free floating algae in water bodies. Actually, these plants, these were introduced into India. because of that beautiful flowers. But their excessive growth that creates a lot of issues in the water bodies because they are growing in a very faster way. So it is very difficult to remove them. Okay, so in such a faster way it is growing. So it's difficult to remove or completely we cannot wipe out those. So these plants, here you can see the water hyacinth, Iconia. That is a most problematic aquatic weed. Okay, that is a most problematic aquatic weed, Iconia. And this Iconia, it is called as terror of Bengal. And this is causing imbalance in the ecosystem dynamics. Okay, imbalance in the ecosystem dynamics of that particular water body where it is growing. Okay. Then, you know very well, the sewage water which is there in our home and which is there in hospital, which is produced in hospital, that is also, that may contain many pathogenic microorganisms or with so many bacteria and all. You can see in that if you are testing those samples, you can see many undesirable microorganisms. And this kind of water that is disposed into other water bodies without proper treatment. So that may cause serious diseases like typhoid, jaundice, cholera, dysentery. All these things may come because of the improper treatment of water when they are flowing into water bodies. Okay. So, like this, the wastewater from the industries like petroleum industries, paper manufacturing industries, and chemical manufacturing industries and all will be there. So they'll be having not only this microorganism, they'll be having more toxic substances, right? They'll be having more toxic substances with like heavy metals, then some other elements which is having more density, like copper, lead, cadmium, and also like that higher density metals also they'll be having. Okay, and this may create toxic effect. So not only these microorganisms, other toxic materials are also there. So which and all they? Some heavy metals which is having density more than 5 grams per centimeter cube. Then for example we can say lead, copper, mercury and all. So there are variety of organic compounds also which may create this kind of pollution issues. So here some toxic substances. Okay, there are few substances which is always present in the industrial wastewater. Okay, this may go for biological magnification or biomagnification in that aquatic food chain. See here you can see water. In water, this DDT, that is 0.003 ppm in water. In zooplanktons, they will use this water and in them it will be 0.04 ppm. That increase, that level increase. Next comes small fishes. They are using this small zooplanktons, and in the concentration will be 0.5 ppm. Then the small fish which is utilized by the large fish. In these large fish, in that chain, when it is moving to higher level, that concentration is becoming more. Their DDT is 2 ppm. Here, in small fish, it is 0.5 ppm, but in large fish, it is 2 ppm. Then finally, when it is reaching the fish-eating birds, DDT concentration or DDT range, it is becoming 5 ppm, 5 parts per million. Okay. So when it is going to higher level of that food chain, that concentration or that biomagnification level, it is increasing. That concentration level is increasing. That is called as biomagnification. So some toxic substances which are always present in the industrial wastewater, that can undergo biological magnification where in that aquatic food chain. So what is biomagnification? That means increase in the concentration of that toxic substance at each trophic level. Okay. Why it is happening? This is due to that toxic substances accumulating in each trophic level, because that organisms are utilizing that toxic substance. So when it is reaching in that organism's body, they cannot utilize it for body works. Okay, as an energy source, it cannot be utilized. Then it cannot be excreted also. So what will happen? It is moving from one trophic level to another trophic level. When these, like here you can see, lower level organisms are used by the higher organism for food purpose. So it is passing from one trophic level to higher trophic level, and the concentration is also increasing. In successive trophic levels, the concentration is increasing. So when it is passing to next trophic level, and like that one food chain, it is continuing, that phenomenon is called as biomagnification. So the main examples here is DDT and mercury. So in this picture you can see biomagnification of DDT in aquatic food chain. So the concentration of DDT is increased at each trophic level. Here you can see the DDT concentration level is increasing in successive trophic levels, and it is starting from 0.003 ppm. From where? 0.003 ppm it is starting. Here you can see. Then in water, that level will be 25 ppm or 25 parts per million. Then in fish eating birds, it will reach, and through that, see, through successive levels, different levels, it is finally reaching the fish eating birds. So that high concentration of this DDT, that will disturb the calcium metabolism in birds. Okay, so calcium metabolism will get disturbed in birds when the DDT concentration is increasing. So higher concentration of DDT through biomagnification, that disturbs calcium metabolism in birds. So that causes thinning of eggshell. Okay, so that causes thinning of eggshell and the premature breaking of those eggs. So that causes, when that thinning of eggshell is becoming thin and it is premature breaking is more, means again next generation it won't get produced, right? That percentage it won't be able to keep. So what will happen? There will be a decline in the bird population, right? So in that particular population, there will be a decline in birth population. Okay. So some toxic substances are there which is present in the industrial waste. When it is going from lower level to higher level due to biomagnification in that food chain, that level or the concentration of that particular material is increasing at successive trophic levels. Why it is happening? Because toxic substances, when it is accumulated by an organism, that cannot be metabolized or that cannot be utilized or it cannot be excreted also. So what will happen? It will pass from one generation to next, one trophic level to next trophic level, and like that it will reach the higher trophic level. So that phenomenon, that is called as biomagnification. So here you can see biomagnification in for DDT and mercury. So the higher concentration of this DDT that may disturb in birds, that may disturb calcium metabolism. If calcium metabolism is getting disturbed, that may cause eggshell thinning, then premature breaking, and it may cause the decline in the bird population also. Right? So there will be a decline in the bird population also. Next comes eutrophication. So what is eutrophication? Eutrophication is the natural aging of a lake by nutrient enrichment of its water. In a young lake, the water is cold and clear, supporting little life. See, when time goes, along with that, these streams that may drain, that may drain into a lake. Then we can introduce nutrients like oxygen and phosphorus that encourage the growth of aquatic organism. So nutrients like nitrogen and phosphorus that will encourage the growth of aquatic organism. So when that lake's fertility that is increasing, that plant and animal life also begins. So here you can see in lakes that will be having large mass of floating plants. Here you can see the green color. These are some kind of algae and also you can see floating plants which is a large mass. Then depending upon the climate, then other factors, then size of lake, all these because of that the natural aging of that particular lake that may be counted as thousands of years. Okay, so that process that is called as cultural or accelerated eutrophication. Cultural eutrophication or accelerated eutrophication. cultural or accelerated eutrophication. So during past time and all, in India and all, in agricultural and industrial waste, that became the reason for the eutrophication. So overstimulated, this kind of waste that overstimulated the growth of algae and other phytoplanktons. So that created unpleasant odors. Then dissolved oxygen level also declined, and that disturbed aquatic organism. So at the same time, other pollutants, the other pollutant which is flowing into a lake, that may poison that whole population of that fish which is all aquatic organism which is present in that lake. And later what it will do, it will reduce the dissolved oxygen level. So in that way, literally we can say that lake or that all organism that is facing death, right? Then the heated or the thermal wastewater or the heated wastewater which is flowing out of that electricity generating units like thermal power plants and all, that is also flowing out wastewater which is heated, which is in heated form. So that is also constituting another category of pollutant. See how that is polluting? Because there are so many organisms which is sensitive to this high temperature, right? And sometimes it may cause damage to flora and fauna also, right? So that is the way how this domestic sewage and industrial effluents are affecting, or how it is creating environmental issues. Then wastewater treatment, integrated wastewater treatment. This is a case study again. Like for air pollution, we learned about Delhi case study. Like that, this is also a case study. Integrated wastewater treatment case study. See, the sewage water which is included in the wastewater that can be treated in a integrated way. How we can mix the artificial and natural process. See, in California, this is a case study of California. There, some biologists from Humboldt State University, they created a wastewater treatment process within the natural system. It's not artificial. Within that natural system itself, they created a wastewater treatment process. In that, the cleaning consists of two stages. First one is conventional sedimentation. Okay, in the conventional sedimentation, first filtering and chlorine treatment are given for water. water filtering will be done and the chlorine treatment also will be given. So after that stage, so many pollutants or dangerous pollutants which can uh, pollutants which can still present or still it is remaining in that water. So to avoid that, next which method they will use? So biologists, they develop 6 connected marshes over 60 hectares of marshland. Okay. So what is happening there in that? Biologists, they developed a series of 6 connected marshes over 60 hectares of marshland. Then all appropriate plants, algae, fungi, bacteria and all, they selected into this area, and that neutralizes or they absorb and they assimilate the pollutant. Okay. So what will happen when that water is flowing through that marshland? That will get purified. In a natural way, it is getting purified. Okay. So that's how wastewater treatment, along with the help of nature, biologists develop this in a collaborative way. See, with the help of nature. In that, there are 2 stages: conventional sedimentation by filtering all those metals, chlorine and other 2, by filtering all those things, and next, as the next step, the biologists develop a series of 6 connector marshes over 60 hectares of marshland. So when that proper plants or fungi or bacteria which is seeded into that area, they will neutralize and they will absorb and they will assimilate the pollutant, and so when that water is flowing through that marshes, it will get purified in a natural way. Got it? So this is the case study of integrated wastewater treatment. So next we are going to learn about solid waste in next class. So after this, hope it's clear. If you have any doubt, you can ask me in the next class. So next class we'll be learning about solid waste, then again plastic waste, which is a solid waste, the case study, then agrochemicals and their effects, then organic farming and their chances, then radioactive waste, then greenhouse effect and global warming. All these things we'll be learning in the next class. So hope up to this it's very clear. Go through all these portions, and if you have any doubt, you can ask me in the next class. Thank you. Thank you.